Okay, hello again. So now we're going to be talking about radians, and in radians it might be a little bit strange. It's not as straightforward as degrees, but we're going to see it's for in terms of working with trigonometric functions. This makes a lot more sense than degrees. So radians is really more based on a proportionality of angles and the sectors of circles that they describe. So if we take a circle of radius r, we can a certain angle will determine like a sector or kind of like a slice of pie, and that slice of pie is going to have a certain area, and it's also going to have this boundary here, which we call the arc length of theta, represents the a portion of the circumference. And the way we want to do is we want to compute this area of the sector and the arc length, and then we're going to see that they're proportional to the area of the circle and the circumference of the circle, respectively. Okay, so that's what we want to do. Now, because of that, we're going to let when this sector right here, we say for 1 radian is the angle required so that this arc length right here is exactly equal to the radius of the circle. Okay, so that if you were to cut this part of it right out and straighten it out, it would be exactly equal to the length of the radius. Okay, so what this amounts to is that we define 2 pi radians. We define a radian, and if we define it this way, 2 pi radians is equal to 360 degrees, or 1 revolution. And pi radians would be half that. We divide everything by 2. Pi radians would be equal to 180 degrees, or 1/2 a revolution. Okay, and it's usually so 1 radian that basically is 180 divided by pi degrees, and that on your calculator, this is approximately equal to 57.3 degrees. Now this 57.3, you don't want to use that to convert. Okay, instead it's much easier. You're either going to be multiplying by 180 over pi or pi over 180, depending on which units you want to convert. Okay, so when you're converting radians to degrees, what you want to do is you want to take you want to multiply by 180 over pi. And the reason for that is that you can think of it this way: is this is 180 degrees divided by pi radians, and if your angle is always in radians, then the radians sort of cancel out. Okay, so that's why we multiply, and then we're left with just degrees. When we're going from degrees to radians, we do the other thing. We want to multiply by pi over 180. Okay? And a lot of times we're going to just leave that pi in there. Okay? Sometimes we'll be interested in what the approximation is, but a lot of times we can just go to pi. Alright, so let's just do some conversions here for some practice. 0 degrees, of course, anything times 0 is 0, so this is just going to be 0. And one thing about radians is that when we use radians, we don't actually write down the units. Okay, so sometimes we just write the number. So I know that seems a little strange at first, but it kind of makes sense when we actually use trigonometric functions. Alright, so 90 degrees. What would 90 degrees? Well, we already know that 90 is 1/4 of a revolution, right? So that would be, and 1 revolution is 2 pi, or half a revolution would be pi, so a 1/4 revolution would be half of that. So this would be pi over 2. Okay? And we already know, we can see that by taking 90 degrees and multiplying by pi over 180, and sure enough, that's going to be 1/2 pi, or just pi over 2. Similarly, 180 degrees, well, we already know that's pi radians. 270 degrees, well, 270 times pi over 180. If you reduce 270 by, take 270 divided by 180, that reduces to 3 halves. So this would be 3 halves pi, or 3 pi over 2. 360, of course, we know that's 2 pi radians. Okay. Negative, if 90 degrees is pi over 2, makes sense that negative 90 degrees would be negative pi over 2. 45 degrees, well, 45 degrees is 1/2 of 90 degrees, so it would be 1/2 of this, but if we want to just do this formula, this would be 45 times pi over 180, and actually 45 divided by 180 simplifies to 1/4 pi. So this would be pi over 4. Pi 30 degrees. You can check that this is 1/6 pi, or pi over 6. And 60 degrees, I'll let you check that this is pi over 3. Okay. All right. And these last 3 angles, these are one of the more common angles that we'll be working with. So you really know these conversions by heart for these 3 angles. Okay. What happens if we want to go in the other direction? Pi over 12. Well, we can sort of see what pi over 12 is going to be 1/2 of pi over 6. So it looks like it should be 1/2 of 30 is 15. And sure enough, when we take pi over 12 and multiply it by 180 over pi, we can see the pi's cancel, and we get 180 over 12, which in fact it turns out to be 15. So this is 15 degrees. Okay, and 77 pi over 6. Once again, the pi's will cancel, and this actually is going to be 210, which is what we had before. We saw it before. Okay, negative 5 pi over 6 times 180 over pi. Once again, the pi's cancel, and this actually turns out to be negative 150. Okay, degrees if we want. 2.6, now there's no pi here, but that's no problem. We just take 2.6, we multiply that by 180 over pi. Okay, and do this, we can do this on our calculator. We need our calculator, of course. And I would say we want to be careful because we want to, if you just divide by 3.14 instead of pi, you might lose some accuracy. And since most calculators know what the value of pi is, you might just use that. So we would take 2.6 times 180 and divide by pi. There we go. And we get 148.96. So we'll do. Okay. And we can do the same thing for 0.85. Okay, and that turns out to be 48.7. Okay, and as for how many decimal places you want to, it's always best to err on the side of caution and give as many as you want, but we want to keep things simple here. On your homework, they'll tell you how many decimal places you should go. All right. Okay. So next thing is we have 2 more formulas, and we started off by talking about the arc length and area of a sector. And I just want to show what the formula is. So if theta is in radians, the boundary of the arc length of the sector, that is this part, length of that would be r times theta. and the area, that is the area of this little sector here, would be 1/2 r squared theta. Now, it's important to realize that theta must be in radians. That if theta is in degrees, this will not work. And the reason for that is this is based on the proportionality argument. Okay, and just to give you an example, let me just recall that if we have a circle of radius r, the circumference is 2 pi r, and the area is pi r squared. Okay, these are formulas you probably have seen in another course, hopefully. And if we could take some real simple cases where theta is, let's say, pi, that's 1 revolution, so the sector is this, it's half the circle, so the area is 1/2 of pi r squared. Okay, but this is just the same thing as 1/2 r squared times pi, and pi is theta in this case. The circumference, or the arc length, would be half the circle, half the circumference. So S would be 1/2 2 pi r, and of course the 2's cancel out, and we get just r times pi. Okay, so this is r times the angle. And something similar happens when we talk when theta is pi over 4. Or actually pi over 2 in this case. Sorry, so I'm thinking this is 1/4 of the circle. So in this case, the area would be 1/4 times pi r squared, which is going to be the same thing as 1/2 r squared times pi over 2. Okay, because 1/2 times pi over 2 is pi over 4. Okay, so okay, which is the same as this. So that works, and then you can check that S, the circumference, a quarter of the circumference is equal to this, and that's actually can be written as r times pi over 2. So that's why it does work. Okay, this because of the proportionality. So that's why that works. So let's say if we wanted to find the area and arc length of this sector, where our angle is 40 degrees, and the radius is 30. I didn't really tell what the units are. We'll just assume that it's feet. Okay. And the thing we first have to do is convert this 40 degrees to radians. So this would be pi over 180. Okay. Which is, let's see what I did in my notes. I can do this directly. This can actually be simplified to 2 pi over 9. This is also 0.698. Okay, we'll keep it here at 2 pi over 9, just because it'll make things a little easier. So this is our theta. R, of course, is still 30. Okay, and so our area would be 1/2 30 squared times 2 pi over 9. Okay, which is approximately, well, this is going to be approximately, I think, 314.16 square feet. Okay, and then the arc length S would just be 30 times 2 pi over 9, which would be 60 pi over 9, which is about 20.94 feet. Okay, so these aren't too bad. The only thing is you have to remember to convert to radians when you do this. Okay, so there are lots of problems on homework like this. I'll let you read the textbook. There might be a couple questions about angular speed. You can read about that in the textbook. I don't think you'll see too much of that. But that's all for today, and I'll see you next time. Thank you.